So, well, um, yesterday I created I explained what happened before the Korlibs, and today I'm going to explain the story, the mistakes, and the evolution of Korlibs. As you were able to see, Kotlin Multiplatform is experimental, and I suffered that meaning because I was a really early adopter. So yeah, I suffered a lot of things. So you can now use the libraries in a more polished state. So well, as I explained yesterday, at some point I started to create the Korlibs, and well, in the first place, I tried to monetize somehow by creating a Patreon. It was on the early stages, and that was my first lesson, that it didn't make sense to make a Patreon at that state, because things require several years for people to know and to decide if it works or doesn't work. So well, Korlibs, the meaning of Korlibs is Kotlin coroutine libraries. So I know it's not super original. It's pretty a name. Well, you know. And well, this was more or less the stack of libraries I had. So I had several layers or libraries that didn't depend on each other, and those were maybe KDS, clock, KMN on the first layer of the stack, and then I had KorGE, Korma, and on the next layer I had Korte, Korau, Korim that already depended on KorGE and things like that. And then I had KorGE, and then in the end KorGE. And then I had a few libraries that were not being used by then. And well, at some point this evolved a bit, and well, actually now KorGE depends on crypto. Now, well, we have a few more libraries. Now there is KorGE to play videos that uses both Korim and Korau. But well, a bit chaotic, a lot of things, and well. So as I explained yesterday, I started with Korlibs before Kotlin Multiplatform even existed. I think there was the JavaScript target, but well, it was experimental on one side, and on the other side, there was no common code. So I maybe a couple of years before actually starting with Korlibs, I created a project called JTrunks that was using the Kotlin JVM target that generates class files, and then it converted those classes into actual source code, like a compiler, but with source code that actually worked. And that way you could target JavaScript, Flash, and mobile devices and desktop by using hacks. That was a language for doing that. And well, the Korlibs started with Kotlin 1.1. So the first library I created, I think, was KorGE. Well, actually, there was another library called KTVFS that was the virtual file system virtual file system library that only worked with that, or only provided that, and then it was integrated into KorGE. And I started with KorGE when 1.1 was not even released. It was a milestone, but already provided the coroutines, and since they were available since 1.1, and that was that single feature is one of the huge features of Kotlin that allows to write code similar to Go and to do concurrency without having to either use callbacks or a wait async approach. So it's simpler and easier to write. So yeah, as I said, in 1.1 there was the coroutines as experimental, and well, in the first place I found a few bugs. In fact, in the first milestones I had fewer bugs than before, but well, at some point it stabilized and I was able to use it properly. And I was using Kotlin's coroutines. And at this point, I believe they introduced the coroutine scope. That happened when, I believe that happened when I already had KorGE working and all the libraries there. So I already wrote a lot of code. And well, this change made all my code obsolete, and I had to rewrite almost everything to rethink things. And well, I spent a lot of time also with fixing bugs and trying to figure out why things were not working. So well, the second lesson I had is that using external APIs may break your code super hard. And that doesn't mean that this change was not great, because it was really awesome. I think it was the right choice. But well, it forced me to do a lot of things. And at some point there was Kotlin 1.2, and this version started to support the experimental multi-platform projects. Until that point, I was using JTrunks to target several places. And then I said, well, finally we will be able to target all the platforms directly without using JTrunks, because JTrunks in the end is using JVM bytecode. It's using the Oracle APIs. Oracle already had some problems with Google, and well, I prefer to not use those APIs if I can use Kotlin. So I decided to give it a try and to start migrating everything there. So I tried it, and I had lots of bugs. The code was not compiling. A lot of time with this, but in the end, I was able to make KorGE working with this Kotlin Native on macOS and Windows. That was a really great milestone, and well, it was great, but I had some issues that I'm going to explain now. So the first one is, well, actually Kotlin, one of the things I love from Kotlin is that you don't have null pointer exceptions at runtime, because the language, the nullability types prevents you from doing that kind of nullability, having that kind of nullability issues at runtime. But when starting to use Kotlin Native, once they introduced the memory model, the current memory model they had, we started to face invalid nullability exceptions at runtime. And with established code base that were already working, and well, they were working and the code compiles, but then in the end we have invalid mutability exceptions, and the compilation times when I started this were really bad. I had to spend a lot of time compiling to get in the end an invalid mutability exception. Now the compile times have improved. They are not great yet, but they have improved. And well, the other issue I faced it, especially on KorGE, that is a game engine and requires a lot of performance, is that even despite I have one single thread for rendering and updating, there is, whenever you change a variable or a field or an array, there is some code injected checking if that code is available to that thread. If you are, for example, trying to mutate something that was shared between threads, and the memory model doesn't support it, try to prevent mutating things in a way that could cause issues in several threads. But that, for KorGE at least, was a really pain point because of performance. I had to do a lot of things, and it was not possible for release builds to disable this check. And well, it doesn't add anything at runtime. Maybe it adds when you are developing, but on release builds, it shouldn't happen if you have already debugged that on debug builds. And well, why is Kotlin Native much slower than JVM? Well, that's one of the reasons. And well, the allocations, and they have worked already on try to prevent some allocations when they check if some objects are in the end going to be in the heap or not. But well, in the first places it was slow, and for KorGE was a problem. And other of the things that I had to sacrifice when moving to multi-platform was the automatic injection mapping. For KorGE specifically, and well, in the backends also, I had an injector that used annotations like singleton and prototype to decide how much times to create an object, and it was able to create those objects automatically without having to provide any code. So when moving to multi-platform, I started to have to manually remove these annotations and to manually provide a way to instantiate those classes, something like this: be get, like this uses reified to get the actual class. And well, in the end, this code shouldn't be here. It should be automatic if you have these annotations here. And well, other of the things I suffered with multi-platform was the number of artifacts and the size of them. When using JTrunks, I was creating Java jars that were pretty small, and one per release per artifact. In this case, there is a different artifact, a different file for each platform, for each version, for each package, for each artifact I have. And well, that's a lot of artifacts, a lot of files, and a lot of a lot of space. In fact, even if Bintry is going to be shut down, I reached 90 gigabytes of artifacts just with Korlibs. And I think that's crazy. And this is me trying to count all the bytes on Bintry. I have all the... In the end, my libraries are not going to be used outside Kotlin. They are... Probably doesn't make sense to use them in JavaScript, for example, since I'm using inline classes and things that doesn't make sense in other languages. And also, I created Korlibs to be used on Kotlin. So yeah, I don't need in my case different libraries. It would be nice if there could be one single file with the AST or the source code or something. And well, the other thing that worsened was the compilation times and the deployments and the CI in the end. I started using Travis CI, and at some point I had to stop using it because compiling Kotlin Native just for testing or deploying was taking like maybe 1 hour and a half. I don't remember the details, but the Travis was canceling the tasks, so I couldn't deploy using it. And well, that was a lot of time that I had to spend that I didn't have to do before, because I was using the JVM, and the JVM compilation was pretty fast. And also, well, before using multi-platform, I was publishing the libraries to Maven Central, because I believe I used maybe one single machine. Don't remember if a Linux machine or even a macOS machine. And in there, I had the signature to sign the artifact, because Maven Central, in addition to providing documentation, source code, and things like that, it also forced you to sign the artifacts. And I remember that when I moved to Bintry, when I changed it to multi-platform, I required to use several different machines with Windows, Linux, and Mac for generating those artifacts, and that forced me to sign those things in different machines. So and in the CI, and in the end, it was really hard. I don't remember the details why it was so hard. Maybe signing on Windows, I had issues, but in the end, I decided to not use Maven Central for now, and started using Bintry with the hopes of publishing to JCenter. And well, in some cases, Bintry was slow and had some issues, and sometimes it failed. And when that happened, I had to spend another hour waiting for the CI, retrying the task, and waiting for it to publish, to continue to the next layer of the stack. I'm able to release one layer of the stack, but when I continue to the next one, for example, if KorGE depends on KDS, and I have changed it KDS with something that KorGE needs, I have to make a deploy of KDS, wait for it to finish, bump the version on KorGE, and then publish again. And actually, know what is that, since for multi-platform I had to switch from Maven to Gradle, Dependabot doesn't work with Gradle because it's not a descriptive. it has to actually execute code to actually determine the versions. So the Pentabot doesn't work, so it cannot create PRs automatically. So I have to do this manually. So when I release a new version of KorGE, I just reserve that day just for that. And well, actually, this is another thing that well, wasting that much time compiling, testing, and things that before maybe were 2 minutes, 3 minutes, now we're taking almost an hour, and that was a lot of time consuming, and also using a lot of resources in the server and accelerating the global warming. And the other thing I suffered with this is that with each new version of Kotlin Multiplatform of Kotlin, since for the JVM there is ABI compatibility, so you can create an artifact with an old version of Kotlin and then use it with a newer version of Kotlin, but it is not the case for JavaScript or native. So I have to recompile everything, even if some libraries doesn't have changed it at all. I have to recompile them so they can continue working on Kotlin Native. And I think that this is something I did when I switched to multi-platform too. I think at some point I was able to have all the libraries in one single repository, and that supported me allowed me to compile everything at once and deploy and test everything super fast, and the JVM was fast enough to be reasonable. But as I said with Travis CI, I was not able to have that long tasks testing everything. So I had to split all the libraries, and splitting that had the issues I told you. Yeah, maybe I can release a new version of KorGE without having to deploy KDS because the version is the same. So I don't have to release one version of all the libraries for one single change. But that also means that I have to make one change in one library, then wait for it to deploy, and then make another change and things like that. So I expended a lot of time there. And yeah, this, as I said, despite I believe this was the right choice because I was able to create libraries for the ecosystem, and I think that's great. I didn't anticipate that many issues, bugs, frustration from there, but well, I think it was something that was needed to be. Someone needed to try Kotlin to report the bugs and everything. So at some point we had Kotlin 1.3, and this version introduced inline classes. And this single feature was really great for all the Korlibs ecosystem because the most obvious inline class we have is the timespan one that support creating times. Well, actually, this class was already there, but we had. But whenever you wanted to provide that time, you had to allocate an object, and that was not nice. And the updater, for example, on KorGE was providing the parameters in milliseconds directly as an integer because it was not reasonable to provide a time span that allocates an object and then iterate with maybe 100 of thousands of objects, and then for each one multiply the time by the speed of that view. Things like that was not reasonable. So I used a plain double there, and when inline classes starting to be available, I created a new version of KorGE by using the timestamp. And another couple of samples are the angle class from Korma that allows to provide angles and in radians and degrees, and you can then use in several places like rotations and things like that. And it's much clearer than just accepting something in radians and just putting in there rotate 2 multiplied by the p number. So I didn't want that, and the angle class supports doing this in a same way. And the other obvious improvement was on the Kotlin library that it supports colors, and it has a bitmap 32 class with all the pixels in RGBA 8 bits per component, and this class supported to perform all those color transformations or readings or writings in a way that was much better. So yeah, inline classes also had a lot of bugs since I was an early experimental user, and yeah, lots of bugs, and sometimes it worked, sometimes it didn't work, and sometimes when it worked I didn't know why. But well, it was something that I think improved the overall experience of KorGE, so I think it was nice. And then let's talk about some things I did to improve the productivity at some point, or maybe other of the things that provide more headaches that maybe the things they solved. I don't know, but was the Gradle modules, the Gradle module metadata that was used at some point at multi-platform, so you didn't have to provide the actual artifact for each platform. You could only provide that platform. Then the metadata had information about which platforms were supported and where to find them. But well, as you can understand, this didn't work well in the first place, and it required a lot of time to get it working properly. And even now, sometimes things strange, I don't know, happened, and they are strange. So yeah, it was something that didn't work so flawlessly as I would have wanted. At some point, I created, when I split all the libraries, I had an issue that well, the Gradle plugin required some code to deploy all the artifacts, to configure all the targets, to do all the things you need to do. And when I had a single repository, that code was on a build Gradle, and that was like that. But when I split it in several repositories, I started to have all that code repeated a lot of times in all the repositories, all being the same, and that was not nice. I had a script to update from a template all those files individually, but it was crazy. It was not a really good experience. So I ended creating a Gradle plugin that configured the Kotlin Gradle plugin and all the things like configuring the platforms, figuring out things, fixing or some bugs or issues with the multi-platform, and also preventing me from having to update everything since it was experimental. The tasks changed, the way configuration was made also changed. So this plugin tried to abstract me from that, and in the case they change the tasks or the way it works, this plugin would cover that case, and it worked with convention like Maven. So you provide the name of the artifact, the group ID, and maybe the place to publish it, and that's it. It did everything else. So I think that creating that plugin was something that was saying that the official Kotlin Gradle the Gradle plugin was not that easy. So, but well, it was experimental, so they were trying things, and that's okay. But in any case, publishing to Gradle, to Maven repositories with Gradle, it's not that easy, and with multi-platform, the things were even more complicated. And well, I used to have, since I had all the repositories, all the projects in separate repositories, I had a single repository with Git submodules for each of the libraries, and I used that to download all the projects and be able to go there. But well, here I have a lot of folders, a lot of them, and well, in the end, I still had to go to one folder, committing the things, pushing the changes, going back, adding these, and publishing things, and waiting for the deploy to happen, and well, that was not very practical. So at some point, not too long ago, I decided to stop this, and I created KorGE Next. So yeah, I decided to stop being stupid. I want to make changes on all the libraries. I want to rename, for example, something to make the 2.0 release, for example. And I had to expend a lot of time going to one library, doing something, and refactoring didn't work because they were separate libraries. So well, I merged all them together again and created KorGE Next, and as trying to stop being stupid. But actually, when I tried, I discovered that even with 4 gigabytes of RAM for the IntelliJ, it continues freezing. So yeah, that's a bit sad. Hopefully, in the future, it works better. And other of the things I did was this project that was a Docker image that included Wine and the OpenJDK with Gradle and Kotlin Native already compiled, and created 3 different bash scripts files by using this Docker image. So for example, if you were in a Mac machine with Docker for desktop there available, you were able to run this. For example, run this Gradle Wine script and use it like if it was Gradle, it mounted in the virtual machine the current folder, and used Wine to run Gradle with Java on Windows. So it was able to create the artifacts directly on a Mac machine for Windows and for Linux directly. So yeah, this was a consequence that I hated to open several VMs for testing everything and for making releases. I wanted to try in one single machine as I was used to do. And yeah, I know that the name of my repositories are very bad, but well, they are like that. And well, at some point there was this post about a new memory management for Kotlin Native. Finally, I really think that the current memory model of Kotlin Native is preventing both performance, at least in KorGE, and is a bit complicated. So yeah, I totally wanted this to happen at some point. And well, this is something I would really want to have, and is a C++ target instead of having a Kotlin Native target that uses LLVM. I would like to have a C++ target that I could see the source code. I could suggest or even patch performance issues. And pretty please, I really want this, and this is the only reason I would use JTrunks. So if this happens, I won't continue. I won't try to bring back JTrunks. But in the case I want to support, for example, video game consoles like PS5 or Xbox, things like that, I won't be able to do that with LLVM. So yeah, please, please, yeah, thank you. So the things I learned is that well, I was an early adopter, and yeah, I knew that it could bring some issues, but I stopped. But when migrated to multi-platform, I started supporting JTrunks, and that prevented me, for example, supporting WebOS or other platforms I wanted because of the C++. So, and also spent a lot of time with deployments. Well, all the things I explained that have improved a lot and will improve even more. But when I was the early adopter, it was not the case. And yeah, the good thing is that I really think it was super positive because I created libraries that people enjoy, and I believe it helped with the library ecosystem for the Kotlin Multiplatform. So I think that's the positive thing, and yeah, it has matured a lot and will mature a lot in future versions. So I think it's worth not having to generate the JVM bytecode and do things like converting bytecode from there, since that happens already on Kotlin. The newer versions already have an IR representation for the Kotlin programs that are being used in the latest versions for JavaScript, JVM, and native. So the future. So yeah, in Kotlin 1.5, the JVM IR backend will be the default one, and that is something great because right now, by the way, I try to compile KorGE with this backend, but I don't remember. I think one test is not passing, or there are some issues. I have to check. But well, once we have the same IR for all the targets, I will create an IR plugin for dependency injection for using with KorGE, so you don't have to manually map and manually instruct the program how to construct objects. So yeah, I will be able to recover singleton and prototype annotations, and that's good news. And well, Kotlin 1.5 also will introduce value classes, and I'm super excited for this. So this is like inline classes, but with several parameters. And right now, for example, in Korim, we have the point class that is a tuple of doubles with an X and a Y. And it is immutable because, well, actually, if you create several instances, you are allocating objects, and that's probably not going to work well in high performance code from the very beginning on all the targets. So right now, the code is something like this. And well, it's not really clear. I don't like it. It's mutable. This is mutable. I don't like it. But with value classes, we will be able to make this immutable, use operators, and finally forget about this stuff. This will work like a structure in most of the cases, and we will be able to use vector mathematics without suffering. So yeah, I'm super excited about this, and yeah, that's it. Thank you for watching. Sorry, I had to put this because please, the C++ target, please, and that's it.
All right. Thanks a lot, Carlos, for sharing this history. Basically, told the story using memes. So this is like tremendous amount of work you put there. We'll be around for a couple of more minutes, so feel free to ask questions to us in the Facebook broadcast in the comments. We'll be able to display them here and answer them. As a client of your libraries ecosystem, I enjoyed listening about the scaling and compatibility issues, because this is typically hidden from the client side, and I had no clue that you actually had to fight that much with multi-platform. And I also realized that this is kind of counter advertisement to newcomers to Kotlin, because they may they hope that, okay, multi-platform, it's a great technology, but now they listen to your talk and they may think, okay, I have to run away.
No. This was the story about the struggles doing this, but actually right now it's working pretty nice. I didn't have that much issues right now. The problems I have is because the amount of libraries that is not going to, you are not going to face that problem if you are using, for example, Cloud or KorGE. Those libraries are already published, and you only have to download them, and you have your own code that is not going to be that huge. So this is going to compile much faster. You are not going to deal with all that publishing, and I think the experience is great right now. So I don't want you to have the wrong idea about this. So,
sure.
but well, that was my experience.
Yeah, I guess most of the issues that you had also stemmed from the fact that it was not really stable technology. It was like bleeding edge technology, right? So you were one of the early adopters.
Yeah,
and I'm actually curious if you reported any issues to JetBrains so that they can incorporate this.
Yeah, all the issues I had, I reported them, and most of them were fixed. I think that we are talking about maybe 4 years ago, so things were really different from now, and now this is not the case. This is things I'm facing as a library author, and I think even if it's not stable right now, it is pretty stable, and in the next version, this is going to be even better. So yeah, I think
Right.
this
I
is
guess multi-platform is now in beta stage, right? It's not experimental, it's not alpha, it's beta, so it's actually not that bad. All right. By the way, I heard that you said about Dependabot that it doesn't support Gradle. I actually noticed several months ago that they started some beta, and I used this in my project fsynth. It suggests some like version bumps in even in Kotlin.js project. So yeah.
So you can use a build Gradle KTS for that, or it has to be
Yes.
Gradle. That's
Yes.
nice. When I checked, maybe there was an issue like 2 months old, and it seemed that this was not going to be supported. So I stopped checking.
Yeah, it's something fresh actually. They added this support for Gradle Kotlin and DSL pretty recently. All right, so I see some question. Let me display it. KorGE is awesome. Short question. How many people helps you with it now? From Mariusz.
Well, actually, there are a lot of contributions. I don't really know the number.
But do you have like a constant like number of contributors? Maybe like the people you know that you interact with on a daily basis, something like this.
Yeah, there are some people that have contributed in the past in for some time, but well, it was for some time. So there are a lot of contributors that have contributed in several times. So right now, this is I'm alone working on that directly, but there are contributors.
Okay, that's impressive. Like it's almost like a full-time job. Like I can imagine a small company creating this product, and you are mostly on your own here. So that's like big kudos. All right, thanks, Mariusz, for the question. So is anyone else willing to? Okay, I have some question. Okay, Carlos, it's an inspiring talk. Thank you in the private chat.
Thank you.
All right, so I guess that would be it for today.